Throughout the world, climate change impacts our Earth with extreme droughts, storms, and flooding. This also affects source water quality and sea levels rising. In short, we need to adapt our traditional ways of managing water to alleviate the negative impact of climate change. Although adverse weather cannot be averted, knowing to a higher degree of accuracy when and where severe weather can be expected helps with prevention and recovery. The advanced 4IR technologies play a significant role in modern weather pattern detection. Extreme weather patterns affect source water quality and the sea level rising. In short, we need to adapt our traditional ways of managing water to alleviate the negative impact of climate change. Technology can assist. Join us now as we discuss how 4IR can help us weather the storm.
Good day to everyone who has joined us for our last Cloud Debate of the year, hosted by the University of Johannesburg in South Africa. My name is Catherine Constantinides. We're streaming this event to YouTube, Facebook and Twitter, and I would like to encourage you to participate in the discussion. At the end of the Cloud Debate, there will be an opportunity to win a 4IR tech hamper. There'll be one for each of the platforms. Be sure to stay tuned and answer the question. This year, the new UJ CloudeBate Climate Series tackled the hugely important topic of how the technologies of the Fourth Industrial Revolution, or 4IR tech, could be applied to positively impact the harmful effects of climate change. In April, we debated the issue of clean energy and battery power. In July, we looked at the latest technologies that assist with recycling and reforestation. You can watch these cloud debates at uj.ac.za/4IR. Today, we look at how 4IR tech can help us weather the storm. We now welcome Alex Malapane, and he is from Weather SA. He is currently the Senior Manager of Research and Innovation for Weather SA. Welcome, and it's so wonderful to have you here.
Thank you.
Tell us a little bit about your job, what you do at Weather South Africa.
You see, South African Weather Service is a research-based organization. We do a number of services. Formally, we have two different mandates. One is public good, and the second one is commercial. But the larger chunk of our job is basically on the good work, or the work that we do for the public. And in such a way that what we do is we have got different operations that we run, from forecasting, aviation, marine, research, and a whole lot of different subsections within the weather service. So our duty is to make sure that we are able to secure life or preserve life, property, people around, and also make sure that we give them the meteorological services that they deserve as a country.
That's fantastic. Now, talking about that, so much of the work that you are responsible for is the research and the data. Now, when we look at what you're capable of doing, earlier you told me about the fact that you actually have 3 months of data available to the public, and you kind of work that far in advance. Now, recently, South Africa saw unprecedented floods that took place in Natal. What are the lessons that we take from there, especially knowing that in fact we actually had the data that told us what was going to be coming?
No, thank you so much. And I think the question is very important because it gives us an opportunity to unpack how we actually operate as South African Weather Service. So we have what we call long-range prediction, which actually makes sure that we give long-range forecasting 3 months ahead of time. So if you go to the WMO website right now, you'll realize that we actually have a long-range prediction data that gives you September, October, and November. In the next month, then it will give you October, November, and December. So it's always 3 months ahead of time. And we have got, day-to-day forecast that comes from our forecasting department, which actually gives you a shorter forecasting from 7 days to the day of the event. So when you look at what happened actually in KZN or in Natal, is that the information was actually there prior. But what we lack currently in South Africa is the coordinated manner in which we are able to activate what is required to, preserve lives, for example. Because that event actually required people to be evacuated. So there is no method or anything that can help us to avoid a storm from taking place or floods from taking place. But we need sort of like actors around the table who can assist us to make sure that lives are preserved. So when we give information, we distribute our information to about 140 radio stations, television, social media, Twitter account. If you go to our Twitter account right now, it's very active and there's a lot of followings. But the issue is not the information that we give to people. The issue is what do we do when the information is given out to the community? How do we synthesize the community? How do we give them early warning so that they're able to understand that this is something that needs to be done in case something like this happens? So there's a lot of actors that are really need to be in place. We work closely, for example, with the National Disaster Management Center, where we distribute some of our warnings to them so that they can help us to distribute to their provincial disaster centers and all that. But it does not end there. You still have the municipality, you still have schools, you still have the community, you still have, places where I will say Gogo Dlamini stays, where there's no signal for her to listen to the radio or to even watch TV. How do we take the information to those kind of people? How do we take the information to Gogo Dlamini staying in a rural Umgugundlo, for example, in KZN? How do we take the information to a school that is in a remote area where kids are still, has to go through rivers and all that? So it's very important for us to understand that we need some sort of public, private partnerships so that we carry this mandate and preserve lives. So it's not only incumbent upon the South African Weather Service to do that. We're already given the information, but the information needs to be interpreted, need to be in a language that is understandable, need to be in a format that can be understandable by the people so that action can be taken place in the ground.
I think you make such an important point. You are providing that information, that research, that data. And it's important then to create these partnerships and bring around the table the people who can coordinate efforts much better. Now, talking about these efforts that we need to, work towards, the things that we need to do, the lessons that we take out of the Natal disaster specifically, how do we use technology to better equip us moving forward in order for us to reach the communities that we need to reach? You are currently using the best kind of technology available to you, and perhaps you want to share with us a bit of the technology that Weather SA uses to predict the weather, and how do we use technology and 4IR to move us forward into a space where we can be better equipped and create partnerships where we're able to activate in a manner where we are making sure that we are not just becoming reactive to the situations that we find ourselves in when we're looking at these crises that take place?
Look, South African Weather Service works within the ambit of the guidelines that are provided by the World Meteorological Organization, which is WMO. And some of the cutting-edge technology that we are using, we have high-resolution, CCAM model that we are using. We've got a unified model that we're also implementing. We are working in partnership together with UK Met Office. We have got other cutting-edge technology that give us, for example, models that assist us to predict weather more accurately. And like I said before, we have systems where things like your long-range forecasting assist us to actually give us more information ahead of time. But some of these things, the cutting-edge technology that we have and the 4IR that we actually require as a meteorological office, are more costly, and that's why we need more capital injection and investment from government, and not only from government, even from the private sector, because there are actors around the table that need to help us and assist us to be up to date. So if you look at, the challenge that were brought by COVID-19, for example, it's very difficult because even the financial status of the organization is not at where it's supposed to be. So to deliver that, from the personal perspective, you still have challenges. From, other things, you still have challenges. So for us to actually move in a space where we have cutting edge technology, for our technology that can assist us, it's still a dream that we really need to achieve. But the models that we currently have are capable to still do the job, even though we can improve. I mentioned the issue of going, social media route, where we are now, activating some of the things, the warnings and the things that we are doing via social media. But I think for us to have a more, impact and all that, the tools that are required for us to move forward, they will really, really require capital injection from government and from the stakeholders around the table. So we are not at where exactly we have to be as a WMO center that is envisaged in the technological space or in the digital space. So we still have a long way to go. And that's why, it is important for us to really begin to have that kind of partnerships around the table to make sure that we leverage some of these things. That is why we go out looking for partners like your universities, because universities are the center of knowledge, and they're generating knowledge each and every time. So we try by all means to look for organizations like your universities where we are able to partner with them and then solve some of these complex problems that we have. So some of the technologies that we currently have, some of them are even aging because they've been invented like a long time ago. So we need more and more, and that requires us to have financial muscle as an organization to carry out, such a mission. So I will say to you right now that our capabilities in terms of 4IR are really, really struggling, and we really need to move forward and give that particular picture that we are looking for. But finance and budgets and all that are really constrained, that are really shortening our capability as the South African Weather Service.
I see. I think it's the partnerships again, and making sure that we find a way to take the data that you are providing, distilling that, but creating an opportunity for all those partners to actually play a role and to bring their resources to the table as well. We also see an unbelievable catastrophe that's taken place around the world. We saw the Pakistani disaster with, the unbelievable floods that we saw happening there. We've seen during the summer, European summer, we've seen droughts and we've seen flooding. How do we use technology to give us an opportunity to better equip ourselves as a global community? Because climate change is a huge factor when we look at weather patterns. And we have this technology available to us, but are we using it to the best capability possible when we're still not able to avoid the loss of life that we're seeing happening in different corners of the world because of the impacts of climate change on different extreme weather patterns throughout the world?
No, I think we're doing our best as the country. Credits must be given, because each and every day when you wake up in the morning, you still get your weather forecast available. Like I said, it's available 3 months ahead of time. Closer to the event, 7 days before, you get all those things. But if you look at the things that are actually happening around the world, more especially with the recent Pakistani, storms that are taking place and floods, those need to serve as sort of like a lesson for some of us, especially here in Africa, in South Africa. What do we do? How do we better plan for that? How do we, avoid 400 people plus dying like the recently happening in KZN? How do we preserve life more? What kind of strategies are required? So once you begin to enter in those territories, you will realize that you are now getting outside the mandate and the scope of the South African Weather Service. Now you need partners that are actually in that space who can actually help us to activate those angles, because we as the center that is responsible, or as the organization that is responsible to give warning alerts, give weather, information and all that, it is not enough for us to preserve life. If you look at what is happening in Pakistan, people are dying. You can't, things like events that are happening, severe weather events that are happening are unstoppable and unavoidable. But better planning can take place. You need to work with people that have authority to evacuate people. You need to work with people that have required, transportation. When such events are coming, who is going to transport people from one place to another? You need somebody who can take the information directly to the people. Now, when you look at South African context, we need to now start thinking about how can mobile networks, for example, assist us, because everyone has a cell phone. How can they assist us in distributing the alerts? How can they assist us in making sure that the information filters to people who missed maybe weather information in the morning or the forecasting in the morning or a night before? So those are the things that we really need to begin to think as the country and see how do we forge ahead and how do we enter into such space and make sure that the actors around the table are able to connect, take the information to the relevant people, and the relevant people that are supposed to take decision on the ground in the communities are actually empowered and trained so that such events, when they take place, they know what to do. So if you look at the things like training, we need to begin to train. We need to go around, collectively with all the actors involved to see how do we, train our people to interpret weather stuff, to interpret weather, alerts, so that they understand and take, precautionary measures when such is about to happen. And going back to understand how, do we take advantage of the technology. Unfortunately, like I said, it is not only about what South African Weather Service can do. Mm-hmm. It's a multi, stakeholder involvement exercise that need to take place. So the technology that we have allow us to predict these things, see them ahead of time before they can happen. Mm-hmm. But after observing such and after having those things, recorded, how do we then move from there to the impact base? Because now people now begins to start to understand if alert is on alert number 7 and this picture or this graph looks like this, what does it mean? Do I have to now drive to the next, town? Should I evacuate? What happens? Because that is the part that really need to take place so that lives are preserved. So we have campaigns that we run. We have things that we do on YouTube where we give people, training, teachings and all that from our DRR side, because we have got a disaster risk reduction section or the department within the South African Weather Service that tries by all means to make sure that these things are in place. But we cannot do it alone. We need other actors around the table. We need other people to assist us so that we are able to preserve the lives. So the technology is there and the technology is active, but it needs stakeholders engagements to take place so that we can activate and have a holistic system of how we're going to approach this in the near future.
Alex, thank you so much. I will ask you one last thing. For you, what are the 3 lessons that we take out of the Natal disasters as Weather SA? What are your 3 biggest lessons that you move forward with as an organization?
I think the lesson that we had there is that we need to prepare and plan better. Mm-hmm. That's number 1, because I think while we knew that this severe weather event is about to take place, the parties that are supposed to be involved were not coordinated enough. That's why the disaster happened like that. So that's the lesson. We need to better plan for the future and make sure that all our systems are not only in paper and in approved plans, but they actually can be implemented and they can be practical. So lesson number 2 is that we really need to start thinking on how do we train our people to understand weather. Because I think the gap there is, even though the alerts were given, even though the alerts are available, but people still didn't understand what action they needed to take. So in terms of us training the community, training the country on what to understand and how to actually implement these things is very important as point number 2. Point number 3 that I think is very important that I can say I learned, or that the lessons learned from this thing, is that life is precious, guys. So yeah. Life is precious. Before we can think about preserving the property, preserving whatever and everything, let's think about life. Moving forward, early warnings should be our talk. We should be looking at early warning system, early warning, method that can assist us to give these things as early as possible. And the lesson that we need to learn there is that early warnings it's a must go. Even the WMO theme for this year during the meteorological day in March was early warnings, because we really need to begin to give people early warnings. And my thinking is that if we were able to give early warnings and they were activated in time, I think the event took place in April. The WMO theme was in March. So we've already been alert to say early warnings are very important, but there was no, coordinated strategy that was required on a provincial level, for example, in KZN. And unfortunately, life is very important, and life is very, very, it's something that we really, really need to preserve.
It's precious. You said it yourself.
Yeah.
Absolutely. Alex Malapane, thank you so much. Senior Research and Innovation Department of Weather SA. In studio, we have Prof. Chris Curtis from UJ's Geography, Environment Management and Energy Studies Department. He's a biogeochemist interested in environmental change in aquatic systems. His studies have focused primarily on the impacts of air pollution and climate change on the ecosystems of upland Arctic, alpine lakes and streams. Joining us online is Professor Tafadzwa Mabaudi, who is a research group leader at the International Water Management Institute's Sustainable and Resilient Food Systems. He is also an honorary research associate professor at the University of KwaZulu-Natal. Prof. Curtis, tell us about your research.
So I've been lucky to work all over the world. I've been working in urban areas, in Gauteng and in Johannesburg, working in Soweto and informal settlements, but I've been lucky enough to work up in Greenland and in Canada and in European mountain lakes and basically lots of different places. But most of my work focuses on the interactions really between climate change, air pollution and water pollution, I would say.
Fantastic. And Prof, share with us a bit of your work as well as a little bit about the International Water Management Institute.
Okay, thank you. So the International Water Management Institute is part of what is called the 1CGIAR system, which is a consortium of global organizations that are mandated with agricultural research. And particularly, we look at the water system, climate, water, and food. And my role within that is to lead a global team focusing on sustainable and resilient food systems across about 3 regions globally.
Excellent. I'd like to pose the next question to both of you. Could you share with us some of the important technologies that are being used within this space and within the work that you and your organizations are doing at large?
So within our space or my space, it's mostly the link to climate information and services and how we link that into the agricultural space through decision support systems to better inform, better equip, better prepare farmers in terms of the various climate risks and hazards. So, for example, a lot of the work is around developing early warning systems for things such as drought, floods, heat stress, disease incidents, and so forth, so that we are generating that sort of information and passing it on to farmers timeously so that they can prepare and mitigate these risks.
Excellent. Prof. Curtis?
So I guess if I'm looking at the technology side of things, there are probably 3 aspects. We could break it down to remote sensing. I'm not a remote sensor, but I work with people who are remote sensors, and they use satellite images, for example, to look at water quality. And this is of very direct relevance in an area like Gauteng, where we have such terrible water quality and invasive species problems like water hyacinth in places like Hotbeesport Dam. So using satellite images, there are sort of entrepreneurial startup companies. If I'm allowed to mention one by name, Cyano Lakes is one that publishes very up-to-date information on the colour of our dams in Gauteng to say how much blue-green algae is in there and how toxic that algae is. And that's of great interest scientifically and for water management, and also of interest to me personally because I have 2 daughters who are involved in rowing. And they've both had rowing regattas cancelled because of poor water quality, sometimes which has been highlighted in advance by the use of remote sensing technology. So Bronkhorstspruit Dam, Wemmerpan, Rudeplat Dam have all had rowing regattas cancelled because of poor water quality.
Wow. That's unbelievable. A little bit earlier, you were mentioning to me your work with acid mine drainage and the situation in Gauteng, specifically Johannesburg. Could you perhaps unpack that a little bit more for us?
Sure. So it's well known that one of the main reasons for the existence of Johannesburg as a large city where it is, which is actually an unusual location for a city on a continental divide between the Limpopo River Basin to the north and the Vaal Orange system to the south, is because of gold. So Igoli, city of gold, I mean, that's why Johannesburg is here. And it's got over 100 years of gold mining. And I guess I would argue that in some ways, the mining industry that made the money upon which Johannesburg is founded was a sort of form of mining the future. It's basically used resources that our children are going to have to pay for because of problems like acid mine drainage that were really not known about when gold mining started in Johannesburg. And this is a problem that's been particularly serious over the last couple of decades as some of the mines have been worked out and as the groundwater starts to rise in the mines until it daylights on the surface and then flows into our rivers and dams. So one of the projects I've been involved in is looking at the Eastern Basin Water Treatment Plant, acid mine drainage treatment plant near Springs. And that's a plant that was commissioned, I think, 5 years ago. It cost something like 2 billion rands to commission, and it treats mine water to neutralise the acidity in the mine water using locally sourced dolomite and limestone. And that's a good thing because it stops very acidic and very toxic mine water from decanting into the rivers that basically flow into the Vaal and into our own water supply. But it's only a partial solution because the treated effluent that gets discharged into the Blesbok Spruit, for example, is very saline water. And so that can have impacts on the nature reserve downstream, the Mare Vale Nature Reserve, but it can also have impacts on us as consumers, on farmers and food producers, because if the water is too saline, you can't use it to irrigate crops, you can't use it to water cattle. And so there are a lot of projects going on nationally looking at alternative technologies and some very cutting-edge technologies like reverse osmosis, which has been around for a while, but is too energy inefficient, too expensive at present to treat these large volumes of water. But the aspiration is to find better ways to use this water because essentially we're a very water scarce country and we can't afford to be wasting water.
Absolutely. Prof. Mabaudi, tell us what are the things that we could do or implement individually in our homes, in our workspaces? What more can be done when we're looking at the protection of water, the impact of climate change on our water systems, etc.?
Okay, thank you. So I think it's a good question in terms of it speaks to the whole aspect of taking personal responsibility in the fight against climate change. So there are small things that people can do within their homes. For example, we in South Africa, it's a water scarce country. We need to conserve water. Part of it is watching how we use water in our households, fixing leaks when there are leaks in pipes, not allowing water to just run off, installing rainwater harvesting infrastructure at your house so that you harvest the rainwater. You can use it to irrigate your garden, your small vegetable garden, and so forth. And also the responsibility at a personal level, because what we saw, for instance, in the recent floods in KwaZulu-Natal and Durban, was also, there was a part of it where we have to take some responsibility because of the way we've been constructing in certain areas that are not meant for construction, where as humans, we are invading certain habitats that are not meant for that, ecosystem degradation, as cultivating on areas that are ecologically sensitive, and that would have been naturally buffers to things such as floods and so forth. So there's a measure of personal responsibility in also our activities. And if you understand climate change, the whole part that distinguishes it in terms of it's the anthropogenic aspect, which is the human activities. And we can do a lot of those. I can go on to things such as carpooling to reduce your greenhouse gas emissions, your footprint as a family, being sensitive or aware of where your food is sourced, how it is produced, all of those things. If we all start making those decisions cumulatively, it has a huge impact.
Thank you so much. Prof. Curtis, what water management issues does South Africa need to actually actively address?
Wow, I mean, where do I start? We're a water scarce country. We only have just over half of the sort of global average rainfall, so we're very water scarce to start with. We have issues of rural-urban migration, so our urban populations are growing, and basically the infrastructure that was built when the cities were much younger can't cope. So I would say that one of the biggest problems is the failure of our wastewater treatment works. And this doesn't need high tech on one level. The engineering solutions are known about. But it's largely a population and a funding and a management issue around wastewater treatment. And then we have the acid mine drainage that we've already mentioned. And as Tafadzwa said about climate change, we have extreme climate change in South Africa. We're predicted to have something like double the global average increase in temperatures. We're expecting more extreme rainfall. So all of these sort of interact. And nowadays, we hear people talk about the water, energy, food nexus and how all these problems are interlinked. But just on the issue of how do we tackle these problems, and you asked the previous question about what can people at home do. I've been working with some NGOs in Johannesburg, ARMA, Action for Responsible Management of Our Rivers, the Bronkhorstspruit Catchment Management Forum. And there are some very motivated individuals in these NGOs doing their own things, to the extent that I've spoken to some of these activists who are trying to design their own monitoring equipment because there's a lack of monitoring being carried out for a whole variety of reasons, but often funding constraints by the relevant authorities, the municipality or the provincial government or so on. And so I've heard of guys trying to use 3D printers to design flow meters or trying to use cell phone apps where you can actually measure the color of water with your cell phone, and if you can calibrate it, then there are certain water quality analyses that you can do with your cell phone. And I think it's fairly well known that cell phones are also being much more widely used now to report incidents. So, in fact, whistleblowing on whether it's failing wastewater treatment works or illegal dumping of rubbish next to our rivers or any other, it's not always whistleblowing. Sometimes it's actually solving the problem. So where we've got burst pipes, one of the big problems is a lot of our water is what we call non-revenue water. I think the figure is something like 30% of all our treated water is not accounted for. If people report that, and if we can make it easier for them to report that, maybe using their smartphones, then we can actually save water, because we are, after all, nationally projected to have a 15% shortfall in water supply by 2030, according to the Department of Water and Sanitation's own estimates. So it's a pretty serious situation that we're facing, and we can't just keep laying the blame on government's doorstep. As active citizens, we have to take some responsibility and do what we can. And I think technology can help us in that regard.
Absolutely. That's fantastic. I really want to thank you both so very much. I think the power of technology and citizenship, Prof, as you've mentioned, taking that personal responsibility, play right in each other's hands. And it's really about how do we use technology that we have access to be able to identify these problem areas and challenges and ensure that in each angle of our communities, we are doing all we can to protect our water systems. Thank you both so very much. Climate change is a result of global warming. What if we could observe our Earth and weather patterns from outside of our world? Cloud Debate correspondent Louis Eckstein speaks to Earth observationist and chief scientist at the South African National Space Agency, Dr. Stuart Bernard.
Thank you so much for joining us from the beautiful city of Cape Town, Stuart.
Hi, Louis. Pleased to be with you.
Stuart, just to start, you've got such an amazingly interesting job. But please tell us a little bit more about your daily job and what you do in your occupation.
Okay, thanks, Louis. So I'm a chief scientist in Earth observation at the South African National Space Agency. So most of what I'm doing is figuring out both internally and with regard to the national landscape, what kind of space-based, i.e. satellite-based products and services we would like, and the research and development required to do that. And even in an ideal world, what kind of South African satellites, we would actually launch to assist us in this. So, with regard to weather and water and climate, we would mostly be looking at ways of looking at, how much water is in dams, the quality of the water, how often it floods, where it floods. And the other aspect of that is not only to look at the water itself, but also how it affects the human population.
Sure. So what sort of technology do you apply? For instance, let's say if you look at dam levels, what sort of technology do you use to determine that?
So mostly what we use for things like dams, and actually SANSA has rather a good water quantity service that's already operational. We would use freely available satellites, which are mostly satellites that look at a scale of maybe about 20 to 30 meters, perhaps once a week. And they look at effectively the color of the surface. Those are satellites that are European or American ownership. And from that, we figure out, for example, how much surface water and water volume there is. And then we can also look at things like water quality. So not South African satellites yet, but we hope in another couple of years there will be South African satellites.
Yeah, no, the whole sort of space area, the whole space sector is so full of very interesting happenings. You know, Apple just very recently, announced a way with the new iPhone 14 where you can communicate with a normal iPhone with a satellite. So there's an incredible amount of things technology-wise happening related to satellites. Now, the technology that you use, is it photography-based? Do you use pictures, or what is it?
We actually use a variety of techniques. So if you, an Earth observation satellite might use something like optical wavelengths, which is much like aerial photography, but just obviously much higher up, 700 kilometers up. And it's kind of very highly quantified. So a good example is something like water quality. You know, if you look at, say, a farm dam and you notice it's a slimy green color, you know, your brain and your experience tells you that there's a bloom of something probably nasty there. But a satellite can go and quantify that by measuring the colors in a much more precise way and applying different algorithms that we or other people might have worked out. And then, of course, the key thing is the satellite is looking at it systematically. So it might be coming over every 5 days for the last 10 years. And that allows you to look at how things have changed. But the other part of the technology that's very important in addition to the satellites is the intelligence that we try and add to what the satellite is seeing. And 4IR comes in a number of ways there. One is, in the last 10 years or so, the amount of satellite data has exploded. There are petabytes and petabytes and petabytes. And we're no longer constrained by the lack of data. We're constrained by the lack of intelligence. There are things like huge cloud compute environments. That's very important. But also things like artificial intelligence that, for example, you might apply to either extracting what's the key message from 10 or 20 years of data, or you might apply, for example, to effectively pictures of something like a human settlement, and the AI will come along and say, okay, you've got X many houses of this size in this area, and it has changed like that. So the intelligence is also a critical part of it.
That's amazing, Stuart. That's absolutely incredible, the way you've explained how 4IR can then add intelligence to this incredible mine of data that you have. It's made me think of a question that I would like to just bounce off you, if you don't mind, and that is, how consumer-friendly are the services that you offer? And with that, I mean, you mentioned a farmer who can perhaps benefit greatly from the intelligence that you guys are gathering. So is it possible at this stage for that farmer to, on his cell phone, have an app that tells him what's going on in one of his dams?
It's very possible, and it's actually happened to some degree. But it's actually probably one of the most important things that we need to think about when we develop these. And one of the key concepts that's taken off in the last 5 years or so is the idea of co-design. So when we go along, let's say we talk to farmers and we wanted to develop a service that provides them with how much water there is, maybe things like the groundwater as well, water quality, and in what's now called precision agriculture or smart farming, you might be providing the farmer, him or her, with an app that says, you need to irrigate this field now. Or based upon the condition of your crop and the weather forecast, you need to harvest in 5 days' time or something like that. So, and that's actually a whole very fascinating field in itself, because it's not only the kind of product that they need, but it's also how they might look at either a computer screen or a smartphone, which are the most common ways of getting the information, and how they gain understanding from that. And in the old days, I'm talking about 10 years or more, because space technology develops at a frightening pace, a really frightening pace. It was enough to just bring the data together. But now that is no longer the case, and you need to be able to design something that takes what we call actionable information, or you need to take a product to someone that allows them to make an immediate decision without, they might not even realize it's actually coming from a satellite, the information. So that co-design aspect and that speaking to the user aspect it's not only a critical part of what we do, but I actually find it probably the most fun and rewarding part of what we do, because you really have to understand all of this decision making, whether it's a small scale farmer, or I and J going out to fish hake, or someone deciding where to build an airport, or whatever it is. You actually need to understand the decision making to provide the right kind of services to enable them.
I suppose it's a commercialization or monetization or commercialization of the data and of the services that you offer. Your agency is a government agency, correct? Yeah,
it's a government agency, but that commercialization can work in a number of ways. Some people regard it as a bad thing, but it is not necessarily a bad thing. So it might work, for example, we want to provide a free service, let's say to small-scale farmers. But we might spend government money on, specialist developers to assist SANSA in providing that service. Or in the case of commercial agriculture, there's already a huge Earth observation market there. So that commercial market in many cases can increase the value of the sector, increase the value of the information, and also because it's competitive, that's also an advantage. So that commercial aspect is something that we have to try and judge. And obviously, in as many cases as possible, we try and provide freely available products and services to benefit the country, because that's our mandate. But there is room for the commercial aspect, that's for sure.
And in that way, I suppose then that you use the technologies of the fourth industrial revolution to gather data so that it can become intelligence that can be used by the community, in the end assisting the country, as you say, with possibly alleviating climate change. Is that a fair statement to make?
Yeah, absolutely. I mean, that's exactly what we're trying to do. So what we're aiming at doing, and SANSA is, we're looking at a new space investment through something called the Space Infrastructure Hub. We're basically trying to bring these threads together, and there's three main threads. One is climate change and its manifestation, typically in extreme events. So floods, the floods in KZN earlier in the year, or drought, or heat waves and fires. We're seeing these manifesting all over the world at a frightening pace. So understanding the kind of longer range climate forecast and seasonal forecast is very important. Then we look at how that affects what we call ecological infrastructure. So this might be terrestrial vegetation, agriculture, forests, the ocean, water resources, etc. But the other very interesting part of it is how that affects the built environment. So human settlements, infrastructure, transport infrastructure, ports, etc., etc. And you use different kinds of satellites to look at all of those different things. And ideally, that brings together, if you look at what's called risk from a climate change perspective, that actually entails three things. One is the hazard, in other words, the flood, the drought, the fire, how the natural world is changing in a way that's going to be bad for us. Sure. The other one is exposure. So, for example, if you've built, let's say, an informal settlement in a floodplain, that's bad exposure. Then the last one is called vulnerability. So this means how is the human response in a particular area and their ability to weather the hazard. So an informal settlement in a floodplain is a classic example of the hazard, the flood, it's going to get you. The exposure, you're in a floodplain, you're first in line when you've got huge rainfall. But then, of course, there's the vulnerability, because if it's an informal settlement, the settlement's ability to respond to that is very poor. So all of those things can be determined to some degree by satellite and additional information and intelligence. And that's ideally the kind of system that we would like to build that provides that kind of information to a variety of end users.
And technology is absolutely central to this, right?
Oh, it's critical. Space, if you think of the satellites themselves, space has changed so much. There's probably a couple of things that have happened even in the last 7 or 8 years. One is that the Europeans started providing free satellite data at an unheard of then resolution, so 20 meters every 5 days. So that changed the way the Earth observation world worked. And then we have what's called new space, where suddenly satellites, instead of being these huge, behemoths that took 10 years to build and $800 million and only countries and agencies would do it, suddenly the private sector started building these satellites because the technology just got way, way cheaper, way, way smaller. And people like Elon Musk started reducing launch costs to, a 10th or 100th of what they were before. So that means we now have many, many more satellites in orbit. So that what we call the upstream, in other words, the actual spaceships, that technology is huge. But the other parts that I spoke about earlier, the cloud platforms, the artificial intelligence, the ability to take petabytes and petabytes of data and reduce it to a single decision point. I mean, that's actually a very, very difficult thing to do. Yes. So that technology has also made a huge difference. Yeah.
That's absolutely fascinating, Stuart, and I'm sure we can talk about this the whole time. I've got so many questions about space to ask you. It's almost hard to stick to the core of our point, and that is that the fourth industrial revolution offers humanity, really, technologies that can directly assist with climate change, and you're at the very forefront of that. So thanks very much for your time and sharing your insight with us. Who knows, we might chat to each other on a cell phone connected to a satellite one of these days. Thanks very much, Stuart.
Thank you, Louis.
Really appreciate your time. Now, this is the real bottom line of alleviating climate change. We all need to strive to reduce our carbon emissions. The Danish city Copenhagen has stated clearly that their goal is to be carbon neutral by 2025. Let's see how they're planning to achieve this.
Cities all over the world are bursting with people. More than half of us live in cities now, and by 2050, that number jumps to nearly 70%. That's a lot of people. So how do we grow cities sustainably? And with the climate crisis, figuring out how we do that is more important than ever before. But there's one city that may be doing it better than any other place on Earth.
We want to become the first carbon neutral capital city by 2025.
So we packed up our gear and headed here to Copenhagen, Denmark to find out how. It's not surprising to learn that 2/3 of the world's carbon emissions come from cities. That number is getting worse as more of us move into cities, which means a higher demand on infrastructure and resources. So Copenhagen is on a mission to cancel out all of their carbon emissions.
My name is Frank Jensen. I'm the Lord Mayor of Copenhagen. When I became mayor, we started this process. We decided that we would want to become the first carbon neutral capital city by 2025.
What does carbon neutrality actually mean? For a city, it's creating more renewable energy than the dirty energy it uses. It's all about achieving a net zero. And their plan is focusing on mobility, pollution, and energy.
We have introduced a lot of new solutions in Copenhagen. Our bicycle infrastructure is world famous because today 62% of the Copenhageners use the bike for daily transportation.
Everyone in Copenhagen bikes, and I mean everyone. So the city is leaning into that. In the last 10 years, it has invested nearly $300 million to improve biking infrastructure. All that money is paid off. There are more than 5 times the amount of bikes than cars in the city. That goes a long way when cutting down on carbon emissions. But the effort doesn't stop there. Copenhagen has totally transformed their waterways too. Only a few decades ago, the harbor was contaminated with industrial waste, oil spills, even dead fish.
When I moved to Copenhagen back in 1987, this harbor was so polluted you could never dream to have a swim in this harbor. But today you can swim. We have a harbor bath where people can have a swim with their kids after school or after job.
Though Copenhagen has made huge strides with their mobility and pollution efforts, by far their biggest focus is on energy use. It makes up about 80% of their carbon neutral plan. To cut down on their consumption, Copenhagen uses one of the world's largest and most successful district heating systems. It works by using a network of pipes to capture leftover heat from electricity production, then delivers that heat to homes across the city.
99% of all households in Copenhagen are linked to our very efficient district heating system. We have also introduced district cooling, where we take the cold out of the water in the harbor and distribute cold in pipes beside the district heating pipes. So you can reduce temperature in buildings, in server rooms, in factories. We can reduce electricity use for cooling down buildings with 70%.
To come up with these kinds of sustainable solutions, Copenhagen collaborates with partners across the city, like Copenhagen Solutions Lab, an incubator for smart city initiatives.
What Copenhagen Solutions Lab does is actually solving some of the bigger problems in the world by using technologies in order to accelerate this transition into a carbon-free economy. So for instance, the problem of air quality. People in cities are dying too early because of bad air, and that is a global problem, not just here in Copenhagen. Getting rid of our waste, measuring air quality, managing traffic. We're trying to solve these problems down in Street Lab.
Contrary to how it sounds, the Street Lab really isn't a laboratory. It's a 2-kilometer-long chunk of downtown Copenhagen that serves as a testing area.
Placing a lab such as this downtown in a real urban environment makes it very realistic. Everything we're testing here will be able to survive in other parts of the city and will be able to be scaled to a city-wide level. This is a new generation of technology that makes it possible to measure air quality by a sensor. And now we're looking into mounting sensors actually on a Google Street View car to make it possible to measure each and every street of Copenhagen.
With these sensors, the city can better locate the source of pollutants to help improve overall air quality. The technology has already proved so useful that Marius and his team are shipping sensors to countries like Norway, Mexico, Austria, Greece, and the US. Though Copenhagen is leading the way in sustainable smart city solutions, experts and policymakers will tell you that the true secret to the city's transformation is the people. The residents here actually want to help build a sustainable city and are willing to work for it.
The citizens of Copenhagen, they demand a high quality of urban life. They are willing to do a lot themselves. They want to sort their own garbage. They want to bike to work. Citizens' involvement is key to the way we think in Denmark and in the Nordic countries. And that's a huge driving force behind being a carbon neutral city by 2025.
Since I became mayor in 2010, we have a growth rate in the number of citizens with 20%. And even that, we have cut our emissions with 42% in the same period. So we show that you can have growth, green transformation, if you do the right investments in the city.
Copenhagen's transformation hasn't been easy. And of course, their size and wealth helps. But they've made it work for their city. Regardless if they hit their carbon neutral deadline, their ultimate goal is to serve as an example for cities everywhere.
The green transformation of cities and livability, and also, very important, good economy goes hand in hand. I see Copenhagen as a front runner to show for my colleagues and decision makers, you must go green.
And now to win a 4IR Tech Hamper. Send us your innovative ideas on how to save water to the email address on the screen below or in the comment section, and that is marketingbrand@uj.ac.za. If you missed any of the 3 episodes of the Cloud Debate Climate Series, visit uj.ac.za/4IR. And while you're there, you can check out the incredible 4IR in Action UJ stories and the Beyond Imagining magazine. Thank you so much for joining us today and for the great engagement on the various platforms. Good night.
The University of Johannesburg, the future reimagined.